So hello and welcome, and today what we will be doing is to generate a synthetic dataset using Ragas, and then we will answer the synthetic questions by using a RAG pipeline and evaluate the results in Langsmith. So first things first, what we will be doing is to set our Langsmith API key with the tracing set to true, then the name for our project, and our OpenAI API key. So for generating the synthetic test data, we will be using Ragas, as we have said. We need to prepare the data to load our PDF using the directory loader, and with the PyMU PDF loader, this document will be split into the pages. So next, we must say that Ragas uses a knowledge graph approach to create this data, and we will be needing a generator LLM and a generator embeddings. So this generator LLM will be in charge of creating the questions as well as summaries, headlines, etc. And the generator embedding will be useful for the relationships. So we instantiate this here, then we create the knowledge graph, we add our documents to our knowledge graph, 64 because we have 64 pages, then we apply a set of default transformations that will enrich our nodes with these summaries, headlines, and themes, and also will establish the relationships between the nodes by comparing these embeddings using cosine similarity. So here we have applied it. We have a whooping 711 relationships. Next, we can save our graph, and then using this graph, the embedding model, and the LLM, we can instantiate our test set generator. But we want queries, different kind of questions. We want questions that are single hop specific, so they can be answered from one document. They are specific tied to a name entity. We want also multi-hop abstract that came from multiple sources and that need a little bit more of reasoning and synthesis. And we want multi-hop specific, so they come from more than one source and are tied to specific entities or details across docs. So we use this test set generation and we generate our test set, which will be of size 10 using this query distribution. But all that we have done, we could have done it by using the abstractions or the shortcuts that are provided in Ragas, which is an awesome framework. So we applied again this. We instantiate again this test set generator, and with the method generate with launching docs, we create our dataset. Let's look a little bit at the dataset. We have our user input with the synthetic questions that simulate different personas in different scenarios. We have our reference context, that is the actual chunk that has been taken for context, and we have our ground truth or the ideal answer or reference. Now we can move on to creating a dataset for Langsmith. So we instantiate the client, we create the dataset with the dataset name and description, and next we will need to iterate through the created Ragas dataset to fill a newly created dataset with a format that Langsmith expects. Next, we create the RAG chain. As always, we use our recursive character text splitter to split the documents. We instantiate our embedding model, which in this case will be text embedded to small. We create our vector data store, quadrant vector data store in memory. We create the retriever. And now the augmented part of RAG. We create the RAG prompt template, instantiate our chat prompt template. And for generation, we will be using GPT 4.1 mini. Finally, we can set up our RAG langchain expression language chain. As always, we get the question to populate question, we get the question, pass it to the retriever to populate the context, which will be passed to the RAG prompt that we pass to the model that generates the response, and the parser, the string output parser, will parse this response. To check the behavior of our chain, we invoke it, see the result, and next we can go with the Langsmith evaluation setup. We instantiate our evaluation LLM, which will be GPT 4.1. Next, we create a set of evaluators, this QA evaluator that evaluates correctness, so does the model's answer semantically match the reference answer? It compares the prediction to the ground truth answer using the question for context. Next, we have the label helpfulness evaluator, which evaluates helpfulness as a label criteria. So the judge sees both the model's answer and the correct reference answer and decides per this rubric. Is this submission helpful to the user, taking into account the correct reference answer? Lastly, we have the dopeness evaluator, which evaluates dopeness as an unlabeled criteria. There's no ground truth. The judge scores the response purely against the rubric. So is this response dope, lead, etc. We evaluate using our chain, our dataset, our evaluators, and we label the chain to make it easier to find it in Langsmith. So here we have it, the results. And as we can see, our application is not at all dope. So let's go to dopify our application. What we will be changing is our template. We will make the style more broad to ensure high levels of dopeness. We instantiate again at our newly chat prompt template. This time for the recursive character text splitter, we are going to use a larger chunk size. And why? Because changing chunk size shifts the recall precision trade-off. So by using larger chunks, we hope to capture more relevant text, increasing recall. And we will be using also a larger embedding model. And why? Because we hope that by upgrading to a larger model, it can capture subtle semantic relationships and contextual nuances that the smaller model may miss. Next, we instantiate again our vector store, our quadrant vector store in memory, the retriever, and the chain. We check for how this chain behaves, and we evaluate. And what can we see? So correctness, we can see no change in correctness. Dopeness, we have gone from 0 to hero. Why? By changing the chant prompt template. And lastly, helpfulness. We can see a slightly improvement in helpfulness derived from changing our chunk size and our embedding model. So what does it mean? That we have successfully retrieved more meaningful context. Thank you so much and hope you have enjoyed this video. Bye bye.